Data communication cables. Wires from your terminal to modems to computers to printers and to controllers. Cables are needed everywhere you use computer equipment. 90%, perhaps more of these cables, are 25 connector type, also known as RS-232 cables. RS-232 cables seem to cause more than their share of grief and trouble. Missing cables, wrong wire configuration, wrong sex on the ends, loose connections, undocumented cables, solder shorts, the trouble list goes on and on.
Hello, I'm Russ Strayer from Data Communication Brokers Incorporated. In this session, I'd like to leave you convinced that cables are not mysterious, that they are easy to make, and that you can make up professional quality cables yourself. You will see the step-by-step procedures that lead to professional results you can repeat again and again. Professional results mean electrically sound connections, clean and neat-looking results, and good documentation. You will be developing a useful, basic skill. The rewards are efficient time savings for you and happy users with working equipment. A professional final product depends on quality tools and quality materials. The basic tool set consists of the tools laid out here: a flat blade screwdriver, a Phillips head screwdriver, needle nose pliers, side cutter, wire cutter stripper, crimping tool, and insertion and extraction tool. The crimping tool and insertion and extraction tools are designed specifically for crimp style pins and sockets. Why crimp style and not solder style? Crimp style connectors have several advantages, and mainly you don't have to solder. Soldering requires a soldering iron and 4 hands. I'll demonstrate. One hand holds the solder, second the soldering iron, third the connector, and fourth the wire. 4 hands. Soldered connections are difficult to change out in the field. In the field, you ought to have the solder, soldering iron, perhaps a small vise to hold the connector, a solder sucker, and an outlet strip and/or extension cord. If you use a battery-operated soldering iron, your batteries will tend to run down just when you are about to use the iron. Soldered cables can have cold solder joints with no electrical conductivity, and dripped hot solder can burn you and ruin good clothes.
So, we strongly recommend crimp-style connectors. They are easy to make and change either in the shop or in the field. This entire session is based on crimp-style connectors.
The crimp connectors consist of pins, sockets, and shells. The male species of crimping connectors is this pin. The female of the species is this socket. Here is the 25-position shell for the male pins. The shell is tapered from the 13-position row toward the 12-position row. Very small numbers are molded onto the plastic of the shell. Number 1 is here, 13 over here, 14 back here below the number 1 position, and 25 just below 13. Pins are inserted from the back of the shell. Here is the 25-position shell for the female sockets. The shell is tapered to mate to the shell for the pins. Position 1 is here, 13 here, 14 back here below the number 1 position, and 25 below 13. The hoods for shells have these parts: 2 plastic halves, 2 screws and nuts to hold the halves together, 2 screws and special washers used to fasten the completed cable to your equipment. A cable strain relief. The hoods are suitable for soldered or crimp style cables.
Step 1 of the cable making process is to select the cable. We suggest you use cable with only as many wires as you need. Why pay for 25 conductor wire when 12 or 8 or 4 conductor will do? Make the cable long enough to reach, but not so long that it gets in the way in your installation.
The cutter stripper tool is used to cut back the outer insulation. Cut back 1 inch to 1.5 inches. Don't cut too deep, or you may damage the wires inside. The cutter stripper tool is used to strip individual wires too. Match the strip size with the wire gauge you're using. This wire is the most common, 22 gauge. If you select a gauge too small for your wire, you will damage one or more inside strands, leading to future broken wire troubles. Strip back just 1/8 of an inch to 3/16 of an inch. The stripped wires can now be crimped onto the pins or sockets. The pins and sockets have 2 flags at the crimp end. The back flag will go around the wire and insulation, and the front flag crimps the wire only. The crimping tool has crimp areas in the front labeled A through G. For these pins and sockets, A is used to crimp the bare wire and E is used to crimp the insulated wire. Insert the front flag in A. Insert the wire in the flag and crimp tightly. Pull the pin out. Turn the tool over, insert the pin to crimp the rear flag over the insulation, crimp tightly. Give the pin and wire a tug to be sure you have a tight fit. The gold flashing ensures good electrical conductivity. For a Y connection of 2 wires into 1 pin or socket, strip the insulation back farther. Both flags will be used to crimp bare wire. The insulation must come off to allow the pins or sockets to seat completely in the shells.
Before you insert the pins or sockets into the shells, document the cable. The documentation should be consistent and clear.
At DCB, we suggest simple drawings like this. Label the ends as pin or male or socket, that is female. Number the connections. Draw the connections. An outward pointing arrow is a pin. Inward is a socket. Crossovers are drawn like this, keeping numbers in sequence. Jumpers are drawn like this. It may be helpful to document cable colors and the RS-232 signal. You should use the same color sequence all the time. A good color coding for cables is the resistor color coding. There are several remembering aids. A good one for polite company is blackbirds raid our young gardens behind village gray walls. That stands for black, brown, red, orange, yellow, green, blue, violet, gray, white. Insert the pins and sockets according to your documentation. Black, brown, red, orange, and so on. The copper-colored end of this tool is used for insertion. Set the pins firmly. The silver end is used to remove pins or sockets. Slip the silver end around the wire, grab the wire and tool, and remove. If the tool breaks back 1/4 of an inch to this hole, don't worry, the tool only works better. Male pins into female sockets won't go. They get stuck, won't come out, and you waste the shell. Cables can be checked several ways. One check is visual. Compare each end with your documentation, each end with the other end. A volt-ohm-meter can be used to check end-to-end continuity. The best checking method is a cable tester. The cable tester checks all 25 pins in sequence. To use this cable tester, set the mode, open all dip switches, insert the cable to be tested. Press clear, press load, adjust the scan speed as needed. The lights walk down in the same sequence as the cable connections. Here are a couple of cable testing examples. The first cable has connections on pins 1 through 8, 15, 17, 20, and 22. Here is our documentation. Now do a visual check. Using the cable tester, watch the lights walk down in sequence. Adjust the walk to faster then slower to suit your own pace. The second cable is a 4-conductor crossover. Pins 1 and 7, the ground leads, go straight through. Pins 2 and 3 are crossed over. A visual check verifies that. Using the cable tester, you see the lights read 1, 3, 2, 7 with a 2 and 3 sequence reversed. The cable hoods can go on when you are sure the cable is correct. Put the 2 shell bodies together. Seat 1 nut, put in the screw, start the screw into the nut but don't tighten. Seat the second nut in place, the second screw, and turn a couple of turns only. Don't tighten yet. Put the 2 retainer screws into their washers. Hold the 2 halves of the hood apart enough to insert the retainer screws. Put in the cable strain relief and tighten. Only now should you tighten the 2 halves of the hood together. Wait until the retainer screws are in place and the cable strain relief is in place before this final tightening. After your cable is made, label it. It is especially important to label it if the ends are not both wired identically. Suppose the cable is non-symmetrical. One end has jumpers, the other doesn't. Once the hood is on, the user can't tell which end is which. In these cases, it is vital to label both ends. There are a number of commercially available marking systems from Brady, Panduit, and others. For low-volume cable making, it is easier to use office supplies. Office supply marking materials include self-adhesive labels or writing directly onto the cable hood. At DCB, we suggest a numbering scheme as follows: 25 for 25 conductor wire, 12 for 12 conductor wire, or 8 for 8 conductor wire, and so on. MF for male-female, or MM for male-male, or FF for female-female. 25 for 25 position shells. 6 for 6 feet, 10 for 10 feet, 25 for 25 feet, and so on. X if it is other than straight through, that is, a crossover. J if it is jumpered. So a 12 conductor, 10-foot cable, male to female, is 12 MF 25-10. In addition to the numbering, keep documentation as we discussed earlier. There you have it. Cable making in a nutshell. The process is easy, fast, and produces professional results. Your reward will be working systems.
This concludes cable making. You can see the process is fast, easy, and professional. Crimp-style cables are easy to change out in the field, too, without the mess and bother of soldering. Use the proper tools, document, test, and label your RS-232 cables, and you will have professional results every time.